Hello friends, welcome back to my channel. Today we are going to see simple technique of how to design a foam pad model in any mechanical software. You can see in the image, after putting the coordinate value of x, y and z, this edge point will come. Now you can see the image, that is the back pad STO. Back pad STO means back pad which is going to provide a support to our back seat trimming, and that is the cushion STO. Now we are going to see creating a back sections. So we have created a edge point using the given coordinates. Create a plane which is normal to the flat plane of the back frame. You can see in the image, through a edge point, that plane passing through the edge point. After that, create a plane parallel to the y is equal to 0 through the edge point. Create cutting plane parallel to the two planes, spaced minimum distance 100 millimeters apart. You can see in the screen section plane setup for the back pad. The highlighted flat B surface which is parallel to the flat surface, edge point will come there. It is passing through the two planes having the 100 mm distance, and in the vertical direction you can see the planes. It is maintaining the 100 mm and total number of planes having the 6. Now creating the cushion section. Similar to that, create a edge point we have already created, passing through the line. Create a plane that is normal to the best fit of A surface, passing through the edge point. Next, create a plane parallel y is equal to 0 through the edge point. Create a cutting plane parallel to the two planes to maintain the distance of 100 millimeters apart. You can see in the image. Those are the section plane setup for the cushions. Cut planar sections through the STO with the cutting plane created. After creating the intersection line, you can see in the image, back and cushion STO with section cut. The red highlighted planes are the planes, and after that we are taking the intersection curves. At this point, the design technique will carry over for both back and cushions. To create a cushion pad, the designer should follow the same step to be successful. Most STO, that is seat trim object data, is surfaced from a scanned trim or scanned part. This can lead to an unsymmetrical model, since the majority of pads are design intent symmetrical. The sections which were cut need to check for symmetry. See picture on the screen. We have drawn the two lines. One is the center line of the pad and other one is the bolster line. Bolster line, it is the pink line. You can see the green curve which is little bit oversized. That means the bolster is unsymmetrical STO A surface, which is very much clear from this image after taking an intersection curve. The pad is not symmetrical. At this point, it must be determined what the design intent is. Does the pad call for high or aggressive bolster, or does it require low, shallow bolster? Once this is determined, the design can choose which side of seat trim object to use to create a symmetrical pad. If the design intent is for an asymmetrical pad, then follow STO, that is seat trim outline given. Before going ahead, we should have to confirm it whether the given STO, that means that input data, is symmetrical or asymmetrical. What is required now is to take each section and duplicate the STO geometry by breaking the curve into usable parts. The designer will need to separate the bolster, sides and insert into a separate curve. The design philosophy requires that each seat component will be separate. The bolster and the insert cannot be on one curve. The picture you can see on the screen. See the center line of the pad, and from this image you can see the pink line at the center, that is the insert line, and green side you can see that is the left hand side of bolster and right hand side of the bolster. Now the STO section is broken into individual areas that can now be used to set up over and underbuild, which will then be used to establish the foundation of the surfaces which will make up the solid model. You can see on the image scan surface section. Now we are going to develop the overbuild and underbuilds. We are going to see the how to develop the overbuilds and underbuilds. Listed below is the step-by-step process of developing over and underbuilds for back and cushion pad. By following these steps, the designer is ensured of making a free-form pad. When trimmed, will give the customer what they are really looking for. In step 1, if the curves in the specific section being worked on not true radius, then create a circle which best represent the curve. The reason for this will come up later. Create an horizontal line tangent to the high line of the bolster in the specific section that is being worked with. Look at the picture on the screen to get a good idea. We have drawn a line passing through the bolster high line which is tangent to the circle. Next step, offset the line and curve of the insert and side panel the equal amount of plus pad thickness. The thickness of the plus pad are supplied by the quarter scale or the trim engineer. You can see in the image the bolster side we have offsetted by the 3 mm, that is the laminate thickness of the side panel is 3 mm. So in the left hand side and right hand side you can see in the image that red line which is 3 mm offset, and at the insert side thickness of the insert panel is 6 mm offset inside the surface. You can see in the image. Step number 3, create a circle which is tangent to the high line of the bolster and the offset side curve with radius of 60% of the STO radius. The next thing to do is trim the insert offset curve to the center line of the seam supplied by the STO or quarter scale. You can see in the image we have drawn a circle that is R1 multiplied by 60%, which it is mentioned, so 0.6. Offset side curve, you can see the red line, and the green circle radius is the R1 we have to be considered. Bolster high line is mentioned. Insert the offset curve which is 6 mm inside it. Center of seam based on the standard. In this diagram we are considered the STO radius part is R1, and we have drawn two circles which is represented in the red line, which is R1 multiplied by the 60% is 0.6. In the next step 4, create a curve which is tangent to the new circle created in step 3 through the end point of the trimmed offset insert curve with a radius that is equal to the bolster radius on the STO. See the screen. Look at the image. You can see that the trim offset insert curve is here, same as R2. In the red line you can see that bolster curve for the underbuild. Step number 5. Since most pads are symmetrical, the geometry that was created can be mirrored about the center line of the pad. If the design intent is for the pad to be unsymmetrical, then repeat these steps for the other side of the pad. In the image you can see it is completed the over and under build. The above technique and philosophies are common with both back and cushion pad as well as with the center line section. Repeat the above technique for every section, and the center line section, when completed, the model should look something like the first picture on the next page. Model should look like this image. See on the screen, overbuilt and underbuilds on each section. Now we are going to see the creating the slab surfaces for the bolster sides and insert for the foundation solid. Now we are going to see the bolster surface. Look at the image. Create points at the intersection of the bolster curve and the insert curves. Do the same on the intersection of the bolster curve and side curve. Next, by eyeballing the points, determine which point is further best inboard and outboard. Create a planes parallel to y is equal to 0 through both the points, since the surfaces need to extend beyond the intersection point. Create a plane 10 mm parallel to the plane previously created. See picture on the screen. You can see these are the two planes. One is passing from that point and it is offsetted by the 10 mm. Similarly, and you can see the point is passing from the plane and it is offsetted. That plane is offsetted by the 10 mm. Now trim the bolster curve to the new plane and then create a point on the end of this trimmed curve. See the image on the screen. We have trimmed the curve. Now the limits of the bolster surface can be created. It should be easier to create a good smooth curve with minimum number of control points, since the points are on a plane. When creating the curve, it is best to try to fit a circle or a conic or arc or spline in that order through the intersection point. A smoother surface is achieved using these elements. We should have to concentrate. We have to prefer the conic, first of all circle, then conic or arc or spline. The hierarchy of these elements is critical also. A circle uses less control point than a conic, and conic uses the less control point than an arc. The curve does not need to pass directly through all the points. If circle won't work, then try a conic. If conic won't work, then try an arc, etc. You can see the image on the screen uses a set of points in which the best curve to use was an arc. It also shows a representation of the curvature of the curve. Each CAD system has different way to analyze curves, but the general idea is for the curvature analysis to show the smoothness, not spikes or hard angles on the analysis curve. Repeat the same step listed above for the other limit curves. Now limit of the bolster surface are complete. They should look like the image on the screen. The midpoint of the bolster curve were created to help get the driving curve for the bolster surface. Creating the driving curve is the next operation. The midpoint that were just created need to be projected on two different planes. One plane should be parallel y is equal to 0 and the place of the construction geometry. The second plane should be one that is normal to the line of the site of then the insert surface placed of the construction geometry. Now the curves can be created using the same technique used when creating the limit curve. Once these two curves are created, they need to be combined together back on the construction geometry. The curves should be projected along the normal lines of the plane that they were created on. See the image on the screen. The points and the curves on the projection plane as well as the final curve on the geometry. The projection direction is normal to the plane where the curve were created. Now the surface can be created. The middle curve is the curve which gives the surface the desired shape and contour. It will be usually have curvature in two directions, hence the extra effort used to create it. You can see the image, the surface, and since the pad is symmetrical, the surface for the other bolster created by mirroring the original surface above the center line of the pad, which we have considered it is the symmetrical. Look at the image on the screen. That is the completed bolster surface. Now we are going to see the side surface. These surfaces are created in the same fashion as the bolster surface. First create the intersection point at the side curve and the back curve. Do the same on the intersection of the side curve and the bolster curve. Now create the bolster curve and the side curve. Create another plane parallel to the back plane through the further revealed intersection point of the side curve and back curve. Since the surface need to be extended beyond the intersection point, create a plane that is 10 mm parallel to the plane we already created previously. The planes previously created. All these steps are shown in the image. You can see that image on the screen. Continue using the same method on the side surface as the bolster surface. Trim the side curve to the plane which were just created and create the end point on this curve. Now create the limit curve through these points as smooth as using the analysis technique mentioned previously. Next step, create the midpoint on the side curve so that the driving curve can be created by using the curve creation method outlined previously. Once all this completed, the model should be resemble. You can see the image on the screen. Driving curve and limit curve for the side surface. Now the side surface can be created if the pad is symmetrical, as most are. The same surface can be used for both sides. You can see the image on the screen, which is the mirror along the pad center line. You can see completed side surface image on the screen. Now we are going to see the insert surface. The insert surface creation uses the same technique as the side and bolster surfaces except for the driving curve. Since the center line of pad profile is the most critical part of the insert surface, the driving curve is created using the intersection point of the insert curve and a plane which is parallel to the y-axis through the center line of the pad. This will allow the designer to create the curve on a plane rather than using the projection curve, as was done when the bolster and the side surface driving curve were created. Again, it is absolutely critical that the surfaces are created as smooth as possible and not deviating too far from the design intent. You can see the image. The insert surface curve needed to be create the surface. Insert curve planners. You can see in the image on the screen. Now the surface can be created. See the image below. See the image on the screen. The completed insert surface. Now all the critical surfaces are completed. At this point, it is time to close the pad out and create a volume which will be represent the foundation solid. The surfaces that make up the top and the bottom and back of the pad are generally surfaces that have curvature in only one direction or are a planar. This type of surfaces are foolproof and should be no problem to create. Usually, these surfaces can be created by driving the curves cross section of the back, side or bottom along a line or an axis. After creating these surfaces or planes, they need to be trimmed back to each other to box out of the volume. The picture you can see in the image, the surface trimmed back to each other, the back, top and bottom areas of the pad are planar with the planes being shown. Surfaces trimmed to each other and planes. Now the volume can be created and the solid created from the volume. This should be very basic step regardless of the CAD system being used. This is the foundation solid. The rest of the pad should be created using only solid. As can be seen, there are only 5 to 8 surfaces needed, and if, for example, the bolster need to change, then because of surface history, only a curve need to be modified, not the whole pad for local change. The result is model with a small number of surfaces and a large number of solid operations that are easier to modify than surfaces. See the image on the screen. That is the solid created by volume. The next step is to provide the fillet to the sharp edges of the solid. You can see on the image here is why the smoothing of the surface curve is critical. The fillets are dependent on the quality of the surfaces that are being filleted. If there are spikes or sharp edges on the curve analysis, then the fillet probably won't run. Since the curves are smooth, just about any solid fillet, variable or constant can be used. You can see the image